Welcome back to the Datarekha audio guide. I'm Diya.
And I'm Arjun. Today, the counterintuitive idea that to stay up when a dependency dies, the smartest thing your service can do is deliberately stop trying to reach it.
That sounds backwards. Start with a failure though. Your database goes down mid-query. Does only that one request fail or does it spread?
It spreads, and how it spreads is the whole lesson. Picture an LLM search endpoint. Every request fetches context from Postgres, calls the model, returns. Now Postgres goes slow. Not down, just slow. Each request sits there waiting, holding a worker thread the whole time. More requests arrive, each grabs a thread, each parks. Within seconds, the connection pool is exhausted.
And then even requests that never touch the database get stuck behind the pileup.
Exactly. An unrelated health check, a cache-only read, a static asset, all queue behind that flood. One slow dependency has eaten the entire pool and made the whole service unresponsive. That's a cascading failure, a local fault propagating outward to consume the healthy parts. So we defend in layers. Innermost is timeouts. Never wait forever. Every call gets a connect timeout and a read timeout. People remember connect and forget read. And read is the one that saves you. Without it, a single hung call parks a thread indefinitely.
Next layer is retries, I assume. But I sense you're about to tell me retries can make it worse.
Spectacularly worse. Done naively. Some failures are transient. A blip. A brief rate limit. So retrying is reasonable. But imagine 10,000 clients all hit an error at the same instant and all retry immediately. The dependency faces a wave 10,000 times normal traffic, right when it's least able to take it. That's the thundering herd. A service that would have recovered in 2 seconds stays down far longer.
So how do you retry without forming that wave?
Exponential backoff plus jitter. Backoff means each attempt waits longer. 1 second, 2, 4, 8. Giving the dependency room to breathe. But here's the subtle bit people miss. Backoff alone isn't enough.
Wait, why not? If everyone's backing off, aren't they spread out?
That's the trap. Backoff desynchronizes successive attempts, but not across clients. All 10,000 started together, so they all compute wait 2 seconds and retry together at t equals 2. Then together at 4. Same wave, just moved. Jitter is the fix. Each client multiplies its weight by a random factor. So retries smear across a window instead of hitting as a wall. The storm becomes a drizzle.
So jitter is the per-client randomness. Genuinely sneaky distinction. What else guards the retries?
2 things. Cap attempts at 3 to 5, because past that the user's better off with a fast error. And keep a retry budget. So retry traffic can't exceed something like 10% of normal load. Blow the budget, and you stop retrying and open the circuit, which is the hero of the story.
The circuit breaker, named after the one on my fuse board.
Exactly that. A fault draws too much current, a switch trips, that circuit cuts out. The rest of the house keeps its lights on. Software breakers do the same for a dependency. The motivation. Even with timeouts, if the database is down 30 seconds and your timeout is 10, every request still waits the full 10 before failing. 3 waves of held threads. The breaker makes failure instant once you know the dependency is down.
How does it know? Walk me through the states.
A 3-state machine. Normally it's closed. Calls pass through and it's quietly counting failures in a rolling window, like 5 failures in 10 seconds. Hit that threshold and it trips to open. Now every call returns instantly with an error or fallback without touching the dependency at all. That's fail fast. Microseconds. Instead of waiting on a timeout.
And here's what I think the real elegance is. Opening the breaker doesn't just help my users. It helps the database recover.
That's the insight I'd underline. The open state is silence. A database struggling to come back up does not need 10,000 retries a second on top. It needs to be left alone. So the breaker protects the recovery, fast failure is better UX, and silence protects the dependency in one move. Then after a cooldown, say 30 seconds, it goes half open and lets a few trial requests through. They succeed, it resets to closed. They fail, it snaps back to open and restarts the cooldown, probing gently instead of flooding.
And while it's open, you're not just returning a bare error, I hope.
No, that's graceful degradation. Serve something useful. A cached or stale response with a warning. A cheaper model if the big one's down, static defaults. A search page returns its top 10 while personalization is offline. And if you truly have nothing, a 503 with a retry after header telling the client exactly when to come back, which beats a cryptic 500. A dependency failure should degrade quality, not availability.
Let me make sure I've got the database tying scenario. Do I lose data?
No, and this is reassuring. Postgres is ACID. If the connection drops before the commit, the transaction simply never commits. No partial writes. The data's safe. The pool detects the dead connections and drops them. The breaker trips. New requests get a fast 503. Reads keep going off a replica or cache if you have one. When the database returns, the breaker half opens, trials pass, it closes. Service resumes.
And when a client retries the write that failed, how do I not charge someone's card twice?
Idempotency keys. The client sends a unique ID. The server records that key with its result in a dedup table. On retry, if the key is already there, you return the stored result instead of running it again. That makes retrying charge card or create order safe, even when the first attempt's outcome was uncertain. Same reason you retry a 429 or 503, but never a 400 or 404. Those will never succeed.
And there was one more layer. Bulkheads, the watertight compartments idea.
Exactly. One compartment floods, the others stay dry. Each dependency gets its own pool. Postgres 20 connections. The model client its own 10 workers. The vector store a third. So if the model provider melts down it, saturates only its own pool. It can't reach over and drain Postgres. The failure stays in its compartment.
So the whole stack in one breath?
Timeout so you never wait forever. Retry with backoff, jitter, and a budget so you recover without amplifying. Circuit breaker so sustained failure fails fast and goes quiet. Fallback so you still serve something. Bulkhead so one failure domain can't drain another. Stacked. A dependency down for 2 minutes costs you a 2-minute degradation in that one feature, not a total outage.
Sometimes the most resilient thing a system can do is stop knocking on a door nobody's answering. That's the Datarekha audio guide. See you in the next one.